In this model, uh, we, we are going to discuss about elastic moduli. The elastic moduli is one of the very important quantity to study about the material properties in the forming of mechanical properties. We know about that many properties are there, especially for we know about the mechanical property. The elastic limit is very important idea. But let us discuss in detail in this. Today objectives are introductions about the elastic moduli and also elasticity, followed by the Hooke's law and what are the various moduli of elasticity. Finally, summary of the today's idea. First of all, we discuss about what is meant by elasticity. Elasticity is one of the property when the external force is applied to the body gets deformed in shape and size. The property of which the deformed body tends to regain its original shape and size after removal of the deforming force is called elasticity. Okay, so we have to that is the meaning is one of the forces applied to the system, the body it changes its shape and size. Okay, so it should be maintaining that shape and size and maintaining to come to that stationary position. After removing that particular body, the body regain its original shape is called elasticity. But there is no way of change in that particular geometrical as well as shape of the body. That particular property is called elasticity. So, when you have to talk about the elasticity, we must know about what is meant by the force applied on the particular system. So that is one terms is called stress. Stress is also a pressure. Stress is also nothing but a pressure. This is actually force per unit area. Actually, the restoring force per unit area is called a stress. So it just seen in the diagram is one of the spring is to be attached here. Is a normal spring. So when you want to apply that mass M is to be attached here. That is the spring is to be elongated in this particular particular one-dimensional axis with respect to the distance is x. So when you got applied that the mass is going to be extended in two way, that's going to be 2x. Therefore, systematically the mass is going to be vibrated back and forth in a particular region. Automatically the stress is defined as force per unit area. Force applied in that particular unit area of the geometrical object. The strain is nothing but a cause of the stress. This is called the deforming force is applied. There is a change in dimension to the length or volume or shape of the particular body. The ratio of change in dimension to the original dimensions is called as nothing but a strain. Okay, the stress is a effect and the strain is to be a cause on this particular system. So Hooke's is observed that particular idea. So within the body, within the elastic limit, within the elastic limit, the stress is directly proportional to strain. So we got to apply it systematically. The stress is going to be increases. The change in dimension is also increase within the particular elastic limit. Okay, but therefore the stress is proportional to strain. The stress by strain is equal to one constant. The constant is defined as E, that is called moduli of elasticity. So the dimensional formula for the moduli of elasticity is for the stress is nothing but a force per unit area. Therefore, force is m into a. Therefore, ml t power minus 2 divided by L squared. Therefore, LL will be cancelled up. Therefore, m L power minus 1 t power minus 2. Its unit is Newton per meter square. The strain is a dimensionless unit. So, the stress is nothing but force per unit area. The force of unit is Newton, and unit area is meter square. Therefore, Newton per meter square is a SI unit for that particular elastic moduli. So next we want to talk about the Young's modulus. That is a change in if suppose the force is applied on the system, there will be a change in dimension to in one dimensional way. So in one dimensional way, we can define the Young's modulus of the elastic moduli of the body. Okay, it is defined as the longitudinal stress to the longitudinal strain. Okay, if suppose if you have to consider this particular diagram of length L of the L of the wire, so you just applied in the unit area of cross section A. It undergoes an increase in length L by using that force is to be applied. Therefore, delta L is the mass, the particular wire is to be elongated in such one dimension with that change in dimension is delta L. But therefore, the longitudinal stress is applied to the particular wire is the force is nothing but mg, W equal to mg. Okay, the mass is weight is nothing but one particular force. It should be applied on the unit area. Therefore, mg by f by a or mg by pi r squared. And longitudinal strain is the original length. The change in dimension length is delta L, or it is applied in that formula is small l by capital L. Therefore, the elastic moduli is the longitudinal stress by longitudinal strain. Therefore, F capital L by A into small l. So that is a formula for Young's modulus of the particular wire. And also the rigidity modulus is nothing but a, it should be changed in three-dimensional way. Okay, so if suppose the body is to be applied in a particular system, sorry, you should change in shape in way. There is a change, not change in dimension, but change in shape way. So if suppose that is called one of the cubical boxes, if you have to apply the force F on the particular system in that unit area A, but that particular cube is to be slightly changed on that particular angle theta. This is called a shearing angle on the particular systems. Okay, the cube is to be tangent force applied on the upper force. There is a small change in the dimension. Therefore, the shearing strain is to be called as theta. Tangential force is applied on the system is force per unit area. Therefore, the rigidity modulus G is tangential stress by shearing strain. That's actually F by A into theta. Okay. So that is a formula for rigidity modulus of the particular. And also the another one elastic moduli is called the bulk modulus. But that is actually the total change in dimension in three-dimensional way. So it is defined as the ratio of volume stress to the volume strain. If you have to consider that one particular body of the cubical boxes, it should be there. If you have to apply the force on three-dimensional way, the body has to be the total volume is going to be shrink after applying that particular force. So that is to be changed in elongated and compressed. This same process to be done inside the particular body. So it just concentrated on the bulk stresses F by A and volume strain is equal to the change in volume is small v by actual volume is capital V. So the K is a bulk modulus of the particular material. This is called bulk stress by volume strain. Therefore, F by A by small v by capital V. So that is another type of a bulk modulus. So there are another one is called a Poisson's ratio. The Poisson's ratio we cannot concentrate on the particular stress of the body. So if you have to concentrate on the strain is to be happening inside the body. So you have to apply that one particular mass, a length of the wire is to be considered as length of the wire is to be L, and F is a F or W is to be applied on the applied as a force on that wire. The wire is going to be strain on that particular length is delta L. At the same time, the dimension, actually the total radius, the total dimension, diameter is going to be decreasing in small d. Okay, such that you have to consider as a radius. The radius is going to be shrink on the same way. That type of change is called the lateral strain. So if you are happening in the straight way is called longitudinal strain. Therefore, the Poisson ratio is nothing but lateral strain to the longitudinal strain. But that we go how to decreasing the particular value. So you're just putting a negative delta R by R by delta L by capital L. The Poisson ratio of that particular material is to be started from zero point 0.2 to zero point 0.5. If suppose a zero point 0.2 is to be a less elastic material and zero point 0.5 is a high elastic material. That ratio, if you just compare it, the particular magnitude, so we just decided that it should be a high elastic one or less elastic one comparatively from previous of the three modeling. And finally, summary of the today event is we just talk about what is called elastic modeling. If suppose any of the body, if you want to apply the stress to the particular system, the strain is going to be happening. The stress is proportional to strain within the elastic limit. The stress is proportional to strain. So that is shown in the graphical point. This is actually so if you want to apply that particular stress on that body, the strain is going to be increases up to that particular point of B. This is called elastic. B is called the yield point or elastic limit. After that elastic limit, it is comparatively small, increasing on that strain. It will be change into small position. If you are to the stress is going to increasing, that limit is going to be in plastic way. It any one of that particular point that's called a fracture point is to be arised on that particular systems. So this whole behavior of the material is explained in a single graphical representations in this way. Okay, so with this I conclude of today idea. Thank you very much.